All right. Do you hear me well? Awesome. Uh, yeah, so this is a slightly different topic. It's more about uh, from the perspective of leveraging large lake houses with iceberg and the challenges and how to overcome the data quality challenges there. Uh, I think it's safe to assume that most of people in the room, their companies already migrated the workloads to Iceberg for the Lakehouse. And probably many already started implementing AI agents, which are reading from these tables, answering business questions, doing some business analytics in a more or less automated way. But it's also probably safe to assume that these agents probably are very confident about the result, yet the result may not be correct. How to go about this? So my name is Max Lukichev. I'm co-founder and CTO of Telmai, and this is basically our business. We are helping companies build that trust layer between their data assets in the Lakehouse and their AI through data observability or data quality, like if we talk about 10 years ago solutions. So with the agents, the challenge is specifically when they are reading from the data, first they have to decide which tables to query, how to formulate the query. And when the query is executing, was the data fresh? Was the data complete? Were the values actually accurate in this data? After it rolls up into the answer on a typical business question, what's my investment exposure in the market ABC? It's really hard to tell. So there's that missing piece of building the confidence in the answer and how this can be done. And also, this has to be done at a large scale. Smaller companies, it's typical to see they can have like a few thousand tables. At the larger scale enterprises, it can be up to 100,000 tables. How to decide what to query, which data is good enough to be queried. It's a big challenge. On top of that, there's millions of attributes. Attributes are not equal. Uh, Out of this, really, only a few percent actually worth to be consumed in this agentic world. Even fewer out of this, fewer tables actually drive any business value. And even fewer percentage is actually properly monitored. So it's a big gap right there in that trust in the data, in the results. And if we are looking at across all of these tables, the tables are actually two similar tables are not equal. They can have the same volume, the same schema, but one is actually feeding a lot of important reports. The other one is being read right once in the last quarter. It's an archive table. One is well defined with the metadata, with the stewardship, with various PII data tagging and other stuff. The others is not right. None of that exists. So for the agent, it's important to choose between those two tables, which is actually one properly answering the question. Same applies to attributes. Within that same, even if we identify this is an important table, there's thousands of attributes on the table. One attribute may be used in 50 in 50 different reports, like as a join key, which is absolutely critical attribute. If the join key is wrong or some values are missing, it's going to produce a partial result. The other one is probably just like a debug information on the record. So the problem is, if you are monitoring everything, it's not feasible. Like you have too much information, too much data. It's going to be prohibitively expensive and absolutely noisy. It's going to be just white noise of issues all the time. If you're not doing anything, that's another problem. So the truth is somewhere in the between, right? So how to find that short list of tables, which is actually worth monitoring? And the answer is that your systems probably already have all the right signals. It's just a matter of grabbing the right signals and putting it all together. So in the catalogs, the business catalogs, you already know how's data being consumed, what it means through the business glossary, which attribute, which kind of business terminology it reflects to, how it is classified, is it sensitive data, is it GDPR related, stuff like that, who owns it, and how it connects into a lineage. But the catalog itself is just the beginning, right? It's a good set of information, but it's a little bit of stale data. It's been populated some time ago. The stuff changed. It's not actual. The new reports being generated, ownerships changed, query patterns drifted, and stuff like that. So how to keep it alive? And the answer is you have already the data quality insights, the usage information of the tables. So you just need to bring it together. So the catalog priors, or like these prior distributions, it's like our initial knowledge about the system. By adding telemetry, we understand like how often the tables are queried, additional metadata on the schemas, AI augmentation of that information. We are getting additional telemetry. We are putting this together into the signals so we can now sort the tables. So our idea is create that shortlist, 1% of tables out of thousands, and then implement the data quality on those tables, deeper data quality in automated way. So then it feeds back to the catalog. So the AI agent, which is actually answering the business question, consults with the catalog or any other context. It doesn't have to be catalog. It can be just a separate context, and can confidently say, this is a reliable data, this is less reliable data. So yeah, this is exactly the process I just described. So we score the tables based on the priority, high criticality, low criticality, score critical data elements, the attributes. We are identifying something coming from the catalog, something is not from the catalog. We can traverse it through the lineage, see how the data being used. Even from the PDF reports, we can understand which attributes need to be considered. Then implementing data quality onto those tables and the attributes, writing results back into the catalog, populating, enriching the context, exposing this to AI through the MCP layer, and this cycle repeats because this is a continuous process. Like tomorrow, the new insights, and so on. Again, to make all of that possible, there has to be that connection to AI. So everything which I was just describing is still algorithmic approach. But to automate it, you have to make this available in the AI. So that's where the MCP comes. The point is here, I will specifically kind of focus on two agents. One agent is building the data quality definitions. It analyzes, uses the data quality table scoring, CDEs. It defines what has to be monitored, and data engineering agent actually operates this. When incidents are found, reported, it looks at the lineage, sees what else is impacted, and builds the root cause analysis and prepares the output for the user to actually do remediations if automatic remediation is not possible. This is just an example, like on the engineer agent, the sequence of actions, right? So we found that completeness dropped on one attribute. We pulled this next tool with a lineage. We understood what else is impacted within 2 hours. There was another incident which related to the freshness. So we pieced this thing together to find the root cause, create a ticket, and notify the user with the remediation actions which have to be performed. And then those two agents actually also live together because while going through these steps, it may realize that there's a table which hasn't been monitored, and it has to go back to data architect agent, which will add additional coverage with the monitors to the needed tables. So the key takeaway of this is, at the scale of tens of thousands of tables, you cannot implement reliable data quality without these scoring functions, without understanding really what's important and what's being used, and so on. So a lot of this information already there in the systems. You may have a data catalog. If you don't have the data catalog, you can build something by traversing the metadata and discovering things, going back through the lineage, going back through AI augmented schema definitions and stuff like that. So scoring tables, scoring attributes, catalog, consider building the catalog. It's a good investment to power your AI. And finally, combine these things together. Iceberg as a storage, catalog, data quality plus agents to build that layer. When you are querying the data, you're not only getting it fast, but you also get that confidence score. Hey, this is the result, and I'm 100% sure there was no incident with this. Or quite vice versa. Yesterday there was an incident. Take it with a grain of salt. That concludes the talk. Please, any questions?
Is there any sort of risk of like feedback loops forming with this sort of system where like if certain table is receiving a lot more attention, then it would find more incidents for data quality in that table would have been receiving the attention? Or is that just not something everybody services?
That is true, but that's why it's not just by attention in incidents. There are multiple metrics. It's a multi-metric algorithm, right? You have to consider the actual usage of the table. Like the more it's being used, it's actually good for you. That means that's an important table. But you're right that if there are more incidents on the table, it may get more attention from the monitoring coverage. But the monitors are per attribute as well, right? So it's kind of, yes, some guardrails needed there, but it's actually probably a good thing that you're paying attention to the tables which matter.
Catalog artifacts, queries,
yes. It's a combination. The business catalog gives part of the information. It tells you the ownership, semantic model, the glossary, what each attribute means and stuff like that. Possibly, not always. Additional information is the query logs, how it's being queried, when was the last time refreshed, how often data being written to this table, how many attributes in general used by reports. Another important piece of information, let's say a lot of companies, they may not have data catalogs, but they have a bunch of PDF reports, let's say for regulatory bodies, right? Like for government and whatever. You can analyze these reports and see which data is being consumed in these reports as well. So like these pieces of information are there. It's not always just the catalog where it comes from. Yeah.
This thing partially answered the first slide was going to ask like cataloging is mandatory for this to work. I think you answered it now. So you don't need a catalog.
It's optional. It's nice to have, but if you don't have one, it's not end of the world.
How intelligence detect automatically to detect the CD, or is it like somebody should have already defined?
Yeah, CDs CDs don't need catalog. You can just traverse through the lineage and through all the reports that you have important reports that you have in the system. You can traverse it back and see which attributes are used in those reports. Same with, let's say, PDF reports, right? You can analyze using AI and see what's being used there. This will give you a definition of your core CDEs. Catalog may have a different perspective on that because it was populated by human or another AI. And it's good to combine these two together. So it wouldn't be necessary, but it's nice to have. The more pieces you can combine is the better.
I have my particular data point. Where then so if I already have my CD on top of that, does this fit into that?
Yeah, you can use you can pull this data from Calibra easily. If you want to use Calibra data quality, it's fine. It's just as long as Calibra supports a good MCP to create monitors automatically, then yes, because this engine basically can score the tables, find that needed metadata and use the MCP back to change the definitions. Yeah. Yes. Yeah, that's one of the signals, the query logs. Yes. But we only have like 8 initially. Think I might have the slide here. Yeah, so catalog tags, the usage, like through the query logs, and querying system tables. That part actually depends on the system we are monitoring. Iceberg, let's say if you're querying it, if you have it just through Hive and Spark, you will not have additional metadata. But if you have it, through Snowflake or any other database, like you will have this metadata available. So yeah, the usage, sensitivity analysis, the lineage depth, how many nodes in the lineage, steward coverage, glossary, and schema. So these are the signals being used. Thank you.
All right. Thanks very much, everybody. We're gonna have a quick break. I think let's say until 6:40, and then we'll get started again. I know at the halfway point in meetups, sometimes people leave. So before anybody goes, I'll say thanks everybody for coming. Hope to see you in the second half. And if you are interested in